Okay, so here in section 2.4, we're looking at linear equations. That's really what we've been working with all along here in chapter 2. So we're going to see the same sort of equations that we've been working with. But again, I've put the list of steps that will work for you up on the board. Do the parentheses, clear any fractions, add and subtract, and finally divide. So my first example, I'm just going to do 3 examples real quick here, just as kind of a summary and to remind you of some of the things that we did. My first example, 3 times x minus 2 is equal to 5 times x plus 7 minus 17. So what I noticed first is I don't have any fractions, so I'm not going to have to worry about step 2, which is nice. I'm going to guess most of you will be really very happy when you don't have to get rid of any fractions. So I do get rid of my parentheses. 3 times x is 3x, 3 times minus 2 gives me minus 6. On the other side, 5 times x is 5x, and 5 times 7 is 35. Still have that minus 17 on the end. That makes the 35 and the minus 17 like terms. They can be combined. 35 minus 17 is 18. So now I have my choice of what to get rid of because I have two terms with x's, 2 terms without. I prefer to get rid of an x first, and I'd rather subtract 3 than 5. So I subtract my 3x, 5 minus 3 gives me a positive 2x. Now I have to get rid of the 18. I don't have any choice because I need to move my numbers that don't have the x with them to the other side. So I subtract 18, negative 6 minus 18 is negative 24, and that just leaves me needing to divide by 2 to finish the problem. And you'll see I ran out of room on my board, so I had to kind of tuck the answer over there to the far right, and we get x is negative 12. And there we go. That's a pretty typical kind of problem that you're going to see. I've got 2 more examples that show a couple of things that I really want you to see. The first one's going to have fractions in it. I know nobody likes fractions, but it is what it is. You're kind of stuck with them. So we have to try and we're going to try and help you be as comfortable with them as we can. So let's move on to that one, and then I have one more, and we'll be all done. All right, so here's my second example. You'll notice it took the whole board, so that's really fun. This is me. I like it. You don't have to like it, so you don't have to, I'm weird. I know. All right. This one has a fraction in it, so that's unfortunate. It means we're going to have to, at some point, get rid of our fractions. You'll see I did that over here. We'll talk about that. But first, I got rid of the parentheses. 1/3 times x is 1/3 x. 1/3 times a minus 8, that's the same as doing 1/3 times minus 8 over 1. And so when I do that, I go straight across and I get a minus 8/3. On the other side, 2 times 2x is 4x and 2 times 6 is 12. Now, you could try to do this problem with the fractions in it. But as we looked at in the last section, it's really a lot easier frequently to just wipe out the fractions entirely. On this particular problem, it's not too bad to see that our common denominator has to be 3 because it happens to be our only denominator. That's always nice. But here's the thing. You have to multiply everything by 3. And by everything, I don't just mean these 2 fractions. I also mean the 4x and the 12. So if you look over here where I've done the multiplication with the 3, down here at the bottom, I have 4x and 12. Now, those are nice to multiply by 3, right? 4 times 3 gives me 12x, and 12 times 3 gives me 36, but I have to do it. If I don't, I've ruined the equal sign in the middle. Okay? Only by multiplying everything on both sides by 3 can I guarantee that that equal sign still works. All right, so I also multiply by I use 3 over 1 to multiply by 1/3 x, and 3 over 1 to multiply by 8 over 3. And in this case, that was really nice because it made the 3's just disappear. And so we got x and 8. And so when I bring it back, I get x. I bring down my minus sign, and then there's my 8, and then the 12x and the 36. And now it looks way nicer, right? No fractions. So I subtracted the x. X minus x makes it disappear. 12x minus x, that's subtracting 1x, so we get 11x. Then I had to get rid of the 36, so I subtracted 36 from both sides. That gave me, you can see I'm really trying to work hard to get this all to fit now, but that gave me 11x equals negative 44, and so I finished by dividing by 11. Once I divide by 11, I get x is equal to negative 4, and that's my answer. So hopefully that works. I've got one more example. It's actually not as bad as this one, but it has something that I really think is important that you see. So let's do that. Okay, here's my last example. The reason I said just a second ago that I think this one is nicer, you'll notice I have no fractions. Yay, no fractions. So I have to get rid of the parentheses. So I have 4 times parentheses 2x minus 1 minus parentheses 3x plus 6 is equal to 10. So I distribute. 4 times 2 gives me 8x. 4 times the minus 1 gives me the minus 4. Here's what I really wanted to focus in on with this particular problem. We have this minus sign here in the middle. There is no number written in front of this set of parentheses, but we are still using the distributive property to get rid of them. It's really like having a minus 1. And I wrote that pretty messily, so hopefully you can read that. But it's really like having a minus 1 there. I have to multiply both parts by minus 1. Basically, it's just going to change both of their signs, right? Minus 1 times 3 is minus 3x. Minus 1 times 6 is a minus 6. But what tends to happen is because there's no number written in there, a lot of times people will just put the minus with the 3 and they'll forget about the 6. So I don't want you to do that. So that's why I'm really pointing that out right now. And then we can finish it up. I've got a bunch of like terms here on the left, so I'm just going to put them together. Okay, they're on the same side already. I don't have to do any opposites to try and get rid of anything. I'm just going to do 8x minus 3x is 5x, and negative 4 and negative 6 makes a minus 10. Once I do that, now I have to add the 10 to get rid of it. Right, minus 10 plus 10 gets rid of it. 10 and 10 makes 20. Divide both sides by 5, and we get 4. So there you go. That's basically solving linear equations. These are the most basic equations that you'll see in algebra, but they're super foundational because a lot of the techniques that we learn here apply to the nastier stuff that comes later. Okay, and we're not going to see a whole lot in this particular course. It's nastier, but if you keep going with math, you will. And by nastier, I really mean fun, but you know what I mean. People keep telling me I'm crazy. So anyway, there you go. That's linear equations. Thanks.